Welcome. The topic we are going to discuss in this lecture is I/O interface circuits. Okay. So basically, here we are going to discuss how an I/O interface circuits interfaces with the external world, that is with the I/O devices. So if you take an I/O interface circuits, it interfaces the computer with the I/O devices or the external world. So it has two ends. One is with the CPU side or the processor side, and the other end of interface is with the IO device. Okay, so if you say, for example, this is an IO interface circuit. Okay, this is an IO interface circuit. I'm calling it as IC. It stands for interface circuits. Okay, one end it will have IO devices. Okay, it may be connected to more than one IO devices also. That's not an issue. Other end will be connected with the CPU. Okay, how it will be connected with the CPU means it will be connected with the CPU through a system bus. It will be connected with the CPU through the system bus. Okay, so this is the system bus, that is it includes address bus, data bus and control bus, right? Fine. Now what we are going to discuss in this lecture, in the sense, these IO device end through which the end through which the IO devices were connected to the IO interface circuits, this end is called as port. Each of this is called as port. Each of this end is called as port. Okay. Now this port can be of two types. There are two types of port. One is called as a serial port. The other one is called as a parallel port. One is called as a serial port. The other one is called as the parallel port. Okay. To a serial port, only a serial device can be connected. To a parallel port, only a parallel device can be connected. Now, what is a serial device and what is a parallel device? A serial device is the one which can transmit and receive only one bit at a time. A serial device is a serial IO device is a one which can transmit and receive only one bit at a time. And a parallel IO device is a one which can transmit and receive data in terms of either 8 bits at a time or 16 bits at a time. The parallel IO device can transmit and receive data in terms of 8 bits or 16 bits at a time. Okay, so some of the commonly used serial ports are USB. So today we are using USB, universal synchronous bus or universal serial bus. Okay, this is a serial port, but it's a high speed serial port. It's not a low speed. Okay, that is different. Okay, USB, we have something called as UART, universal asynchronous receiver and transmitter. Okay, and also we have a very famous port, very famous serial port called as RS232C. Okay, which is, if you take all the older computers, it will have this particular port called RS232C. In the present computers also, you can see there will be one RS232C through which you can connect any serial device. For example, say for example you want to interconnect mm, any serial device. For example, if you take Arduino, some of you might have worked with Arduino boards, right? Okay, if you take Arduino board, if you want to connect any device, you have to interface through RS232C, that is a serial port. Okay, so such microcontrollers also comes with RS232C. Okay, right. Fine. So, but this is the overview. Serial port through a serial device can transmit and receive one bit at a time, whereas a parallel device can transmit 8 or 16 bits, transmit and receive 8 or 16 bits at a time. Okay. Now, when you come to the CPU end, CPU will always transmit data in parallel. It won't transmit data in a serial style. It will always transmit in parallel. That is, it will transmit either 8 bit or 16 bits at a time. Let us assume. Okay. Now, for a parallel device, that is not a problem, because CPU is transmitting the data in parallel and the device also want it in parallel, so they communicate directly. Okay, but how the CPU is going to communicate with the serial device? Because serial device want the data in serial, it needs only one bit at a time. Okay, so for that we'll be using something called a shift register. The shift register will help us to convert the parallel data to serial before writing into an IO device. Okay, Similarly, while reading from the IO device also, serial device is going to send the data serially, but CPU want as a parallel data. So while reading from the IO device also, we'll be using shift register, which is used to convert the serial data to parallel and then send to the processor. Okay, so this is a brief overview of what we are going to discuss in this lecture. Okay, so the interface circuits has two. It interfaces the computer with the IO device, right? At the computer end, it has three buses: address bus, data bus, and control bus. And at the IO device end, it has some data path and associated control signal. And this side of the end is called as port. We have two types of port: parallel port and serial port, right? You know what is a serial port and what is a parallel port. Okay. Parallel ports can transfer data and transfer and receive data as 8 bit or 16 bits at a time. Serial port can transfer and receive data only 1 bit at a time. Okay. Processor communicates with the bus in the same way, whether it is parallel port or a serial port, right? So conversion from parallel to serial and serial to parallel takes place inside the interface circuit. Now let us see how to read something from a parallel device. Okay, how to read something from a parallel device. So let us assume that the keyboard is connected to the computer through a parallel interface. Right? Okay. Now if you take a typical mechanical keyboard, it is a collection of open switches. That is, under each key, if you take key A, under key A there will be a switch, and by default this switch will be opened. By default this switch will be opened. Okay. If you take another key B, any key, below that key there will be a switch which is not visible to us. Okay. When you press that key, what will happen? This switch will be closed. When you press that key, this switch will be closed and an electric current will be created. Okay. So once you press the key, the respective switch will be closed and an electric current will be created, and that will be sent to the encoder and debouncing circuit. The job of the encoder and the debouncing circuit is to identify the key that is pressed, and also it should find out the respective ASCII value of that key. Okay. Every key will have an ASCII value. So the encoder circuit should identify the key and it should identify the corresponding ASCII value of that key. Okay. And the debouncing, it is encoder and debouncing circuit. What is meant by debouncing in the sense? Normally we press the keyboard key for few milliseconds, right? But in spite of that, the keyboard may interpret it as multiple presses. It may not, you might have pressed really the keyboard key for only once, but the keyboard might interpret it as two press or three press. These things may happen. This is a common error that happens with the keyboard. Okay. So if such error is happening, then the debouncing circuit will, so identifying one key press as multiple key press is called as bouncing. That is called as bouncing. Okay. So debouncing means it will ensure that such faults are not happening. Okay. That is, if some key presses are wrongly interpreted as two or three presses, then the debouncing circuit will ensure that it is just one press only. Okay. It will make sure that the bounces are debounced. Okay. Fine. So once the data is read, so this is what the encoder and decoding debouncer circuit will do. And once the key is identified and its ASCII value is found, it will keep in the data lines. Okay. And through these data lines, it will get into the data in register of the input interface. Okay. And not only that, after keeping the data, the encoder and the debouncing circuit will set the valid bit 1. Okay. Once the valid bit is 1, after that only the data will be moved to the data in register. Okay. So the IO interface circuit will keep checking the valid signal, whether it is 1 or not. If it is 1, it will understand that okay, some data is available, and it will take that ASCII value and it will keep in the data in register. Okay. So it will keep the ASCII value of that particular character, right? After keeping the data in register, it will also make the SIN bit to 1. It will also make the SIN bit to 1. Okay. Once the SIN bit is 1, the processor will be keep polling the SIN bit. When it becomes 1, the processor will understand that some data is available in the data in register and it will read the data. Okay. So this is how data is read from an IO device using parallel port, right? Okay. So whatever we have discussed, that's what explained here. So here we are assuming that at the processor end we are using an asynchronous bus. You can see here it is not using any clock. It is using master ready and slave ready, the handshaking signal, which is an asynchronous bus. Okay. Next, let us see how to write something to an IO device using parallel port. Okay. So from a keyboard we can only read. Okay. We can write, the processor can write to a printer. So here we are taking an example of a printer, right? Printer is connected to an output interface. Okay. I mean an IO interface circuit, which we call it as output interface, because printer is an output device. And in the CPU end, you can see there are data bus, address bus, the control lines, read and write control lines, and this what you call handshake signals, master ready and slave ready. Okay, right. So now, so this slave ready will be asserted when that in the here also, when the data is available. Once the data is read, the input interface will also assert the slave ready. Okay, this is whatever we have discussed in the previous class. All those things will happen, right, automatically. Fine. So coming to parallel port, coming to writing something to a parallel device, what will happen? Let us see. So if the printer is idle, here the printer uses two handshake signals. One is called as idle, the other one is called as valid. Okay. If the printer is free, that is, if the printer is not printing anything, then it will set the idle bit to 1. If the idle bit is 1, then it means that the printer is ready to receive data. It means the printer is ready to receive data. Let us assume that currently there is nothing in the data out register. Okay. If nothing is in the data out register and if idle is 1, then the output interface will set S out to 1. It will set S out to 1. If S out is 1, it means that processor can write something, can print something. That is the meaning. Processor can send something to the printer and printer is ready to print. So processor will keep polling the printer frequently and it will check this S out. If S out is 1 and if there is some print job pending, then the processor will send those data through the data bus. Okay. I mean, it will send the data through the data bus and it will send the, let us assume the printer is connected through memory map. So it will send the address. So I want to, so this data should be sent to this device 1001. 1001 is a printer. So sent means what? It should be printed. Okay, because printer can only print, right? Now once the data is placed, all the device will start polling. All the IO device will, start checking whether this address is equivalent to them or not. So this particular interface circuit will identify that yes, this address is matching to one of the IO device that is connected with me. Okay, then it will collect this data and it will keep it in the data out register. It will keep it in the data out register. Okay, now data is available. Now data is available and idle is 1. Okay, so what the interface circuit will do, in the sense, it will keep the data in the data bus. It will keep the data in the data bus and it will assert the valid line. It will set the valid signal to 1. So when the printer senses that the valid signal is 1, it will understood that there is some data available in the data bus. So it will start, these data lines, it will start taking this data and it will start printing. So while it is printing, when it is printing, it will again make idle to 0. It will again make idle to 0, which means what? Now the printer is busy. It is not ready to take any data. Now the printer is busy, it is not ready to take any data. Okay. So once again this S out will be set to 0, which means printer is busy. So the processor will not send anything now. Okay. Once this printing is completed, everything is done. Uh, again the idle will go to 1, and if some other print job is there, that can come, right? If everything is completed, if the job is completed, then the IO interface will assert the slave ready signal, which means the job is completed. Okay. So this is how the parallel port, writing something to an IO device connected with the parallel port works, right? Okay. So this is the way parallel port works. Now let us see how serial port works. Okay. So as we know, serial port is used to transmit one bit at a time, and so when you are writing to a when the CPU is writing to a serial device, CPU is writing in a parallel way, right? That should be converted to serial and then it should be transmitted to the device. Similarly, when you are reading, when the CPU want to read something from the serial IO device, the device will send the data in a serial fashion, but it should be converted to parallel and then it should be sent to the CPU. So that will be done by using shift register. So we have two types of shift register. One is called as input shift register. The other one is called as output shift register. So this diagram assumes that there is an IO device to which data to which you can read from which the CPU can read data and also the CPU can write data. Okay. So let us assume here is the CPU. Okay, this is the data bus. CPU is here, right? Okay. First, let us see the input. Reading. I mean read. How to read from a how the CPU is going to read something from a serial device. Say a serial device is connected here. Say let it be mouse or anything, or even it can be a keyboard. Okay, right? Now this device is sending data serially. That is one bit at a time. Okay, and this one bit at a time, whatever the device is sending, that will be stored in an input shift register. The shift register will take all these 1 bits at a time. It will collect 8 bits. It will collect 8 bits. Once this 8 bit has came, then it will send all these 8 bits to the data in register. Now the data in register contains 8 bits. It contains a collection of 8 bits. Okay. After transmitting this 8 bits to the data in register, this input shift register is again ready to receive other bits from the serial device, right? Okay. Once the data is available in the data in register, okay, now now it is available as a parallel data, right? It is a collection of 8 bits. Now this can be transmitted to the computer through the data bus. Okay, either computer will place a request. If the processor places the request, then the IO interface circuit will read the data from the data in register and it will keep it in the data bus. So it can be used by the processor. So this is how reading from an input, serial input device happens, where the serial input, and we have seen here how the serial data is converted to parallel by using input shift register. Okay, let us see how writing happens. Say CPU want to write something to the serial device. So here is the serial device. CPU want to say, let us assume this is a printer. CPU want to print something. Now CPU is going to send the content in a parallel fashion. But this is a serial printer. It needs data in a serial way. So CPU is sending say 8 bytes, 8 bits. There is 1 byte. It is sending 8 bits. So that data it is coming. So it can be either 720 or 027. Okay, here it is. This is the number. Okay. So so the so the so whatever the data the CPU is placing here, it comes through the data lines and it reaches the data out register. Okay. From data out register, it will enter into the shift register 1 bit at a time. It will enter into the shift register 1 bit at a time. Okay. Or from data out register, this entire 8 bits will enter into the shift register. Okay. From the data out, the entire bit will enter into the shift register, not 1 bit at a time. The entire 8 bits will enter into the shift register, and the shift register will shift out 1 bit at a time. So that it is called a shift register. Okay, output shift register. It is going to shift out 1 bit at a time. First it will send 1 bit, then the next bit, then the next bit. Like that, it will send all the 8 bits. When all the 8 bits are sent out, then again the output shift register is ready to receive next set of 8 bits from the data out register. Okay, so here we are converting the parallel data to serial while writing to one parallel IO device, right? So this is how serial data is converted to parallel, or parallel data is converted to serial for communicating with the serial IO device, right? So serial interfaces requires fewer wires, and normally they are used for communicating with devices which are physically distant from the computer. But nowadays we are using USB, which is a serial connection for most of the cases. But it is a high speed serial connectivity. Right? So the speed of transmission of data on a serial interface is called as bit rate. Is called as bit rate. And different devices may operate at different bit rate. It's not that all serial devices operate at the same bit rate. The bit rate may change. Accordingly, the serial interface must be able to use a different range of clock speeds. Okay, right? For example, say for example, some device may operate at a speed of say 200 bits per second, but another device may be operating at 150 bits per second. And accordingly, the clock frequency of the interface circuit should be able to be adjustable. Okay. So these are some examples of the serial interface: UART, Universal Asynchronous Receiver and Transmitter, RS-232C, which is a very old and popular serial port. Right. So that's it about I/O interface circuits. Okay. Let us stop here. Thank you.